Now that we know the derivative of sine and cosine, we can actually derive the derivative of tangent. So since I know that if my function is tangent of x, that's the same thing as sine of x over cosine of x. I want to find the derivative of f of x, so that means I either use the definition of derivative or I can use a derivative rule. Here I'm going to use the quotient rule with sine and cosine as my functions. So that means I'm going to use the quotient rule for tangent. So the quotient rule, remember, is low d high minus high d low over low squared. So the low is cosine, so that's low and then d high minus high d low all over low squared. Now so the things that don't have a d in front of it, I just leave it as it is. So cosine x. And then I have derivative of sine of x. So derivative of sine of x, this piece right here, the derivative of sine is cosine. So I replace that with the cosine x. Now sine of x, the second sine of x doesn't have a d in front of it, so I just write it, no change. And this piece, the derivative of cosine of x, is negative sine of x. All over cosine squared, which has not changed. I don't take the derivative there. So cosine x times cosine x is cosine squared x. And then I have minus sine x times a negative sine x, which gives me plus sine squared x all over cosine squared x. My favorite identity, because it turns something that was ugly into something very pretty, and that is an identity that this is equal to 1. So now I have 1 over cosine squared of x. And I want to express that without the fraction, so I'll flip that and call it secant squared of x. So the derivative of tan is equal to the secant squared of x. So there's another trig derivative. We can follow the same process to all the other trig functions. So we can find the derivative of cotan by using quotient rule on cosine x over tan x, and it'll look over sine of x, which looks very similar to the proof we just did for tangent. And after we do that, we would get cosecant squared of x, a very similar process. We can do that same thing to secant of x. And because secant of x is equal to 1 over cosine of x. So using the quotient rule, where one of the functions is just 1, that's a fun thing to do. So if you do that, so use quotient rule here too, and there you would also find, after doing a little bit of work, you would get the quotient rule, which would be negative tan x times secant x. So the similar technique using quotient rule and the trig identities will get us all the other trig functions, which brings us to this page. So using quotient rule and the other identities, we can find all 6 of these. Notice, and this is a table that you'll just want to memorize, all 6 of those. Do notice, to help you memorize, um, notice that every time you take the derivative of a cosine, it ends up being a negative. So, oh, I'm sorry, with a c, one of the functions, it always gets you a negative. And the ones that are not do not always have a positive. So that's one trick to help you memorize these. But you'll basically just need to memorize these 6 trig derivatives along with the 3 trig limits that we talked about earlier.